Next up, volume problems. Gravel is falling onto a conical pile at a rate of 4 meters cubed per hour, so that the diameter is always double the height. So you've got your gravel falling, makes a pile like this, and we're told that the diameter is always twice the height. Find the rate of change of the height of the pile at the moment the height is 3. Conical means cone. What shape did you think it was?
I didn't know.
Well, you were so adamant to disagree. Okay, so what do we want? We know that height is a function of time. Okay? We know that volume is a function of time. We want to find dH dt. We know dV dt because the volume is increasing at 4 meters cubed per hour. Technically, we also know that diameter is a function of time in this question. But there's a relationship that the diameter is always equal to twice the height. How do we create an equation? Because right now, what is the volume of a cone? That's right. It's always the third of a cylinder, which is kind of cool. So the volume formula for a cone is 1/3 pi r squared times the height. The problem right here is this gives us an equation that relates volume to both radius and height. We want to find out dH dt, so we're going to want to create an equation for our volume that just involves height and volume. Yes?
Get rid of R and replace it with 4H.
So R is equal to 4H?
That or 1.
That or 1. Yes? Okay, you can replace R with D over 2, or I could replace this D with 2R. Okay? So 2R equals 2H, which means that R is equal to H. Which now lets me rewrite my formula as 1/3 pi H cubed. Because I replaced the R squared with H squared, and H squared times H would be H cubed. You could put R cubed, but the reason we want H cubed is we want to find dH dt at a height of 3 meters. So when the height is 3 meters, the diameter would be 6 meters. We want to find out how fast the height is changing. We can now take the derivative with respect to time of this equation. The derivative of volume is just dv dt. Nice thing here, the derivative here, the 3 would come out in front, cancel out with my 1/3. I get pi h squared, and then the derivative of h, chain rule, is dh dt. And we have everything we need to plug in. We know that the volume is changing at a rate of 4 meters cubed per hour. We want to find it when h is 3. 3 squared would be 9. And we're solving for dh dt. Divide both sides by 9 pi. And we should include our units here, so dh dt equals 4 over 9 pi, and our units were meters per hour. Does it make sense that this wouldn't be increasing too fast? Because the gravel would come and most of it would go down the sides. It's still added to the pile. But the cone would increase in height quickly at the beginning and then slow down as it's getting bigger and bigger and bigger and bigger. Okay, so this is perfect for this time of year since it is the middle of April and we have lots of snow. Okay, you could go outside right now since it's above 0 and make a very nice snowball. Make it perfectly spherical. You could bring it inside and the snowball would melt because it's warm enough inside to melt the snowball. And if it melted perfectly, so it wasn't dripping off the bottom, maybe you threw it with spin on it so that it was spinning in the air, throwing off water in all directions, that its volume is decreasing at a centimeter cubed per minute. In other words, 1 milliliter of water is coming off. Oh, not necessarily, because volume of water is slightly bigger. So, but that idea. Okay. But the volume is decreasing at 1 centimeter cubed per minute. At what rate is the radius decreasing when this snowball is this big with a radius of 5 centimeters? Okay, so what do we have? We know that volume is a function of time, and we know that radius is a function of time. We are told that the volume is decreasing. How am I going to show that as a negative? And we want to find dr dt, which as a result, we should get a negative answer. That makes sense. If we're thinking of as negatives decreasing, positives increasing, this is what we want to find. When the radius is 5 centimeters. So again, how do we relate the two? We have a formula that says the volume of a sphere is 4/3 pi r cubed. And this is usually the tricky part in these questions, coming up with a formula relating them. These are easier questions when there's a formula that exists that already relates the two. Our conical shaped gravel pile was a little bit harder because it had more than one variable in the equation, and we had to rearrange it to have 2 variables. We sometimes will get equations with 3 variables in the equation and have to work with those as well. So take the derivative with respect to time of this equation. You will get dv dt. 3 comes out in front, giving us just 4 pi r squared. And chain rule, implicit differentiation says we have to multiply by dr dt. What do we know? We know that the volume is decreasing -1. We want to find it when the radius is equal to 5. So 5 squared would be 25. And so we get -1 over 100 pi is equal to dr dt. If you answered with a statement, is it centimeters? Yes. Per minute, thank you. Had that. So here I don't need the negative because I wrote in my statement decreasing. Right? If you wanted to, if your statement just said the rate of change is, then you would include a negative in your answer. Because there's nowhere that you're indicating increasing or decreasing. Does that make sense? All right, is that our last volume one? Make a little